I'm going to talk to you a little bit about expected value. I hope that when you're done listening to this, you'll be able to answer these questions. What is expected value or expectations? And how do we calculate expected value? Expected value is really about what we expect to gain or lose in the long run. So we average out all the possible gains and losses to see what we can expect to take away in the long run. And that's really a key idea. We're really looking at this in the long run. So we're taking the long view. Let's look at an example. Let's say you want to make some money. Now, I'm not encouraging anybody to bet on anything. This just happens to make a good example. Let's say your friend comes over with a bag that contains 12 balls. It has 5 red balls, 3 green balls, and the rest are yellow. You're supposed to draw one ball from the bag, and your friend says that you'll get $14 if you draw a red ball, and you'll get $12 if you draw a yellow ball. So, of course, if you draw a green ball, you get nothing. So if you were to play this game over many, many days, many times a day, what would you expect in the long run? Well, the first thing we do is we map out the possibilities. There's really only 3 possibilities here. So you reach your hand into the bag. You could come out with a red ball, a green ball, or a yellow ball. Now let's figure out the probability of each one of those possibilities, each one of those outcomes. There is a probability of 5 out of 12 that you'll draw a red ball. So you had 12 balls total, and 5 of them are red. So 5 out of 12. The probability of drawing a green ball, there's 3 green balls in the bag out of 12. So 3 out of 12, and you can reduce that to 1 out of 4. The probability of drawing a yellow, there's 4 yellow balls out of the 12, so 4 out of 12, which you can reduce to 1/3. At this point, it's a good idea to make sure that those probabilities that you just defined all add up to 1, because then you can be pretty sure that you've covered all your possibilities. The next step now is where we're going to take into account our money. So we're going to figure out the probabilities for our gains and our losses. The probability of winning $14 is 5/12. So remember, the probability of drawing a red ball was 5/12, and that's when you win that $14. Remember that when you draw that green ball, you get nothing. So the probability of winning nothing is 3/12, or 1 out of 4. And the probability of winning $12 is 1 out of 3. Finally, we do our expected value calculation. An expected value calculation takes each outcome, multiplies the probability of that outcome times the amount that you stand to gain or lose. So the first term, 5/12 times 14, that's how much you're going to gain in the long run if you draw a red ball. Plus 1/4 times 0, so that's you get nothing for a green ball, plus 1/3 times the $12 that you win if you choose a yellow ball. We do the math and we end up with $9.83. So if I played this game many, many times, then in the long run, I would expect to come out ahead by $9.83. Well, let's change this game up a little bit. Let's say that you have to pay to play. So now your friend's getting a little sneaky. Your friend brings this bag over and says, the same thing as before. We've got 12 balls, 5 red, 3 green, rest are yellow. You can win if you draw a red. You can win if you draw a yellow. You get nothing if you draw a green. But you have to pay each time you draw a ball. You have to pay that $10. How much would you expect to win or lose if you played this game many times? So we start just as we did before. What are all the possibilities where there's only 3? Red ball, green ball, yellow ball. The probabilities of all the possible outcomes, same as before. So the probability of drawing a red ball is 5/12. The probability of drawing a green ball is 3/12. The probability of drawing a yellow ball is 4/12. And now we're going to take into account our gains and our losses. So the probability of winning the $14 with a red ball minus the $10 that you had to pay in. So really you're only coming out ahead by $4, and the probability of that is 5/12. The probability of winning nothing, so that's when you choose that green ball, minus the $10 that you had to pay in because you're not getting that one back, is 1/4. And the probability of winning the $12, of course, minus the $10 that you had to pay in, is 1/3. So this is how our expected value calculation looks. 5/12 times $4 is what we would come out ahead by doing a red ball, plus 1/4 times -10, so if we draw a green ball, we're losing our $10, plus 1/3 times $2. Remember, $2 is what we come out with if we draw that yellow ball. Turns out if you play this for a long time, many times, you stand to fall behind by a total of 16 cents. So you can decide based on that whether it's worth your time and money over the long run to play this game. Let's look at a slightly different kind of example. Should you invest? Let's say you have a company and there's a particular project that you would like to invest in, but you're not sure if it's a good investment or not. So somebody in your company does a lot of financial and market analysis and tells you, well, there's a 35% chance that you're going to lose $30,000 on this. There's a 40% chance that you'll break even, and a 25% chance that you will make $55,000. So is it worth it to invest? Now notice in this very simple example, we're not even taking into account how much money that we're being asked to invest. That is going to change things, but keeping it simple. So what should you do? Well, first let's list out the possibilities. You could lose money, you could break even, you could make money. So let's figure out the probabilities of all the possible outcomes. You could lose money. There's a 35% chance, so 0.35. You could break even with a 40% chance. You could make a profit with a 25% chance. So now we're going to take into account how much you might gain or lose. The probability of losing $30,000 is 35%, or 0.35. The probability of breaking even is 40%, or 0.40. The probability of making $55,000 is 25%, or 0.25. Now we can do our expected value calculation. So our 35% or 0.35 chance of losing $30,000 plus 0.40 chance of breaking even plus 0.25 chance of making our $55,000. So doing the calculation, we end up ahead by $3,250. So perhaps it would be an okay investment. All right, one last example. A manufacturer is considering the manufacture of a new and better mousetrap. She estimates the probability that the new mousetrap is successful is 75%, or 0.75. And if it's successful, it would generate profits of $120,000. The development costs for the mousetrap are $98,000. Should the manufacturer proceed with the plans for the new mousetrap? Again, let's start. What are the possibilities? Well, there's three things that could happen. You could lose money if the mousetrap is not successful, or you could make money. Oh, that should be two things could happen. You'll lose money, you could make money. Now, what are the probabilities of the possible outcomes? Well, the probability that you're going to lose money is 25%. And where did we get that? Well, our manufacturer said there's a 75% chance that that mousetrap will be successful. Therefore, there must be a 25% possibility that you're going to lose money. And the probability that you'll make a profit is 75%, or 0.75. Now let's take into account our actual money involved. So the probability of losing $98,000 is 25%, or 0.25. The probability of making $120,000 is 0.75. We plug that into our expected value calculation, so 25% chance, or 0.25, times a negative $98,000, that's our loss, possible loss, plus 0.75, that's 75% chance of gaining, making a profit of $120,000. So it looks like through our expected value calculation, we could come out ahead by $65,550. Looks like might be a pretty good investment.